Right now, more than a quintillion invisible particles could be tearing straight through your body every single second, and you would never feel a thing. Could we ever actually see dark matter? Let's set the rules first. No settling for computer models. No hiding behind theory. We're asking whether human eyes, or any instrument ever built by human hands, could look directly at the substance that makes up most of the mass in the universe. It sounds impossible. It sounds like chasing smoke through a locked room. But scientists have spent nearly a century closing in on an answer, and what they've found along the way is stranger than most people realize. So what exactly are we hunting for? Dark matter isn't a planet drifting in the void. It isn't a cloud of gas or dust. It doesn't burn like a star, and it doesn't reflect light like a moon. Every object we've ever seen with a telescope announces itself through light. Dark matter refuses to play that game. It appears to barely interact with anything familiar, except through one force: gravity. Here's where the mystery actually begins. In the 1930s, an astronomer named Fritz Zwicky was studying a distant cluster of galaxies called the Coma cluster. He measured how fast individual galaxies inside it were moving, and the numbers didn't add up. The galaxies were racing around so quickly that the visible matter alone couldn't possibly hold the cluster together with its own gravity. Something invisible had to be adding extra pull, extra mass, extra weight to the equation. Zwicky gave that invisible mass a name that has stuck ever since: dark matter. For decades, almost nobody took him seriously. Then, in the 1970s, an astronomer named Vera Rubin picked the thread back up. She studied how stars orbit around the centers of spiral galaxies, expecting the outer stars to slow down the farther out they traveled, the same way planets slow down the farther they sit from the sun. That's not what she found. Stars circling the outer edges of galaxies were moving just as fast as stars near the core. The only explanation was an invisible halo of extra mass wrapped around every galaxy, like a shell nobody could see but everybody could measure. Rubin's numbers were hard to argue with. Dark matter finally had a body of evidence behind it, not just a name attached to a mystery. Let's escalate the question, though. If nobody has ever directly seen dark matter, how do we know it's really there, and not just a mistake buried somewhere in the math? That question led to one of the most convincing pieces of evidence scientists have ever gathered: the bullet cluster. It's actually the wreckage of two galaxy clusters that collided millions of years ago. When astronomer Douglas Clow and his team studied the aftermath, they found something remarkable. The visible gas from both clusters, the heaviest ordinary matter involved, had slammed together and dragged to a stop in the middle of the collision. But the gravitational pull, mapped using a technique called lensing that shows how mass bends light, was concentrated somewhere else entirely, out past all that visible wreckage. Something invisible had sailed straight through the crash, barely slowing down, carrying most of the mass along with it. That's not a rounding error. That's a fingerprint left at a crime scene. But a fingerprint doesn't tell you who the suspect actually is. For decades, the leading suspect was a class of particle physicists, nicknamed WIMPs, short for weakly interacting massive particles. The idea was elegant. A WIMP would be heavy, slow-moving, and almost allergic to interacting with anything, which fit perfectly with everything astronomers were seeing in the sky. Physicists built increasingly sensitive traps to catch one in the act. But as those traps grew more sensitive year after year, WIMPs kept refusing to show up, and researchers had to start asking a harder question. What if the suspect isn't a WIMP at all? That opened the door to other candidates. Some physicists now chase a much lighter, stranger particle called an axion, first proposed to solve an entirely different puzzle in nuclear physics, which turned out to double as a plausible dark matter candidate. Others hunt for dark matter using an entirely different strategy, not waiting for it to bump into ordinary atoms, but watching the sky for the faint aftermath of dark matter particles colliding with each other and annihilating, a signal that instruments like the Fermi Gamma Ray Space Telescope have spent years scanning for near the center of our own galaxy. So far, nothing has stuck the landing. Every candidate remains just that, a candidate, still waiting for its day in court. So we know dark matter is out there. We even know roughly how much exists. Measurements from the Planck satellite, which mapped the faint leftover glow of the Big Bang, suggest dark matter makes up about 27% of everything in the universe, nearly 6 times more than every star, planet, and gas cloud combined. Ordinary matter, the stuff we're made of, is the minority. But knowing something is there and actually seeing it are two very different things. Here's the real problem. Every way we see anything ultimately relies on light. Your eyes catch photons bouncing off a surface. A telescope catches photons that have traveled billions of years across empty space. Dark matter appears to almost completely ignore light. It doesn't absorb it. It doesn't emit it. It doesn't reflect it. It isn't dark the way a shadow is dark. It's dark the way something standing entirely outside the conversation photons are having with the rest of the universe would be dark. So if light can't find it, could we feel it another way? This is where the search goes underground, literally. Deep beneath mountains and inside old mine shafts, physicists have built detectors designed to catch the rarest possible event, a single dark matter particle brushing against a single atom of ordinary matter. One of the most sensitive of these sits nearly a mile below South Dakota, inside a chamber filled with ultra-pure liquid xenon, part of an experiment called LUX-ZEPLIN. The rock overhead blocks out cosmic radiation from space. The xenon waits in near total silence for the faintest possible flicker of light, the kind that would mean a dark matter particle just grazed an atom on its way through. So far, the tank stays quiet. No confirmed direct hit, not from LUX-ZEPLIN, not from its cousin experiment xenon in Italy, not from any detector built on Earth. That might sound like failure. It isn't. Every year these detectors come back empty. Physicists rule out entire categories of theoretical particles, narrowing the list of places dark matter could possibly be hiding. It's less like searching one dark room and more like slowly switching on every light in an entire house until there's nowhere left for the answer to hide. So, could we ever actually see it? Here's the twist. We may never see dark matter the way we see a planet glowing in a telescope lens. But seeing was never really about light hitting your eyes. It's about detecting something real and mapping exactly where it sits. By that definition, we already do see dark matter, just not with our eyes. We see it in the way it bends starlight around colliding galaxy clusters. We see it in the way galaxies spin as if something invisible is gripping them from the outside. We see it woven into the faint patterns of that ancient afterglow from the Big Bang. Patterns that only make sense if dark matter was already there at the very beginning, quietly gathering ordinary matter into the first galaxies. Dark matter was never hiding from us. It's simply invisible to the one sense we've always trusted the most. And maybe that's the real discovery, buried inside all of this. For most of human history, we assumed that if something truly existed, we should eventually be able to look straight at it. A mountain, a star, a distant galaxy. If it was real, sooner or later, light would carry proof of it to our eyes. Dark matter breaks that assumption completely. It forced us to build entirely new senses. Detectors buried beneath mountains, satellites decoding ripples in 14-billion-year-old light, gravitational maps stitched together from galaxy clusters scattered across unimaginable distances, all just to notice something that outweighs every star in the sky combined. Think about what that actually means. Everything you have ever seen with your own eyes, every sunset, every planet, every distant galaxy captured by a telescope, only accounts for a small slice of what's really out there. The rest has been sitting right in front of us the entire time, threading through galaxies, bending starlight, holding entire cosmic structures together, and somehow staying completely invisible to the species that eventually became curious enough to go looking for it. We are living inside a universe we can barely perceive, built mostly from something we've never technically laid eyes on. And the strange comfort in that is this. Not being able to see something has never meant it isn't real. It just means we haven't built the right sense for it yet. A century ago, nobody could see radio waves either, until we built instruments that could. Dark matter may simply be waiting on its own version of that moment. So the next time you look up at a clear night sky, remember this. Most of what's actually out there isn't the light you're staring at. It's the darkness holding it all together, quietly, invisibly, patiently, threaded through every galaxy you can see and countless more you can't. And we're only just now learning how to see it.